Hi, suppose we want to talk about a circle in complex numbers. Now, basically, a circle is represented by the modulus of z minus z1 is equal to r, and we say that r is the radius, and that z1 is a fixed point. And when we say fixed point, we mean it would become the center of the circle. So now this represents a circle, and with the center is z1, where z1 is a fixed point, so z1 could be of the form of the Cartesian coordinate form AB, all right, and it is a fixed point. Now this is our first observation. Second thing I want to talk about is especially when it comes to shading of region. If you've got a complex number like this, now we know that this is a circle and it says here it's less than r. That means the circumference of the circle is not included. What we mean by this is if we were to shade in the circle is going to be something like this. And then that means the broken curve, it means that this is not included. And so we're going to take all the points within the circle, but not the circumference of the circle, because there's a less than the radius here. And also, you may have something like this, less or equal. Now for this one, the radius, the circumference is now included. So you'll have your circle like this, pardon my drawing, and you've got all the points within the circle. Now we can look at some examples. Let's say I give you a complex number, z, minus, let's say 2 plus 4i, and that is equal to 3. So basically now we know that the radius is 3. Radius is equal to 3. And that's going to become our center of the circle. The center of the circle is 2 and then 4, which is a fixed point. That's got to be minus, because originally it follows that it should be minus over here. We're not proving how to get this formula, but we're just trying to know, understand how we can apply the formula and draw what would be required to draw in the exams. So now, sorry, suppose I want to draw this circle. Okay, it's going to be something like this. This is our, sorry. Let's say you've got 2i, 4i. Okay, and now say for instance, this could go further up if I'm not mistaken. And the center is 2, 4. So there's a 2 is here and 4 is here. And our radius is 3. So basically what we're saying is this is 2 and this is minus 2. So 3 would be somewhere here. From 2 to minus 1 is 3. So the next thing is here. And then because it's 2, the radius is 3. So from 2, you add 3. You're going to get 4. And then let's say 5 is somewhere here. So there. In the same way, you're going to come all the way here because that's 3. So 2 and 1 is 3. So 2 and 1 is 3. Circle is going to be something like this. Alright, so there we go. That's our circle. So this is how we, draw our circle. We can look at this second example, And suppose now we've got, let's say example b, z minus 3i, and all of that is less than 4. So again now, let's draw a diagram. Okay. And you've got, let's say 2, 4, 0, now what about this? This is basically our center, and this is 0, 3. Okay, the imaginary part is 3, but there's no real part here. Like here there was a real part 2, right? The real part was 2, but here there's no real part. So 0, 3 is the center. So the center is going to be over here. And then from that center, there's a radius of 4. It comes all the way here. So all the way here. Let's say, now from 3 to 4, you've got 7. So 4, 6, 7. And then from here, you've got 3, 4. Somewhere here. I probably would, listen, this is not really an accurate diagram. We're not looking for accuracy. I'm just looking for the idea of how to draw a circle when we get these complex numbers, okay? So let's say something like this. So your circle is going to look something like this. As you can see, this is not really accurate. So let's say 4 was somewhere here, the other one was here, that one was here, and here. So this is our circle. Now it is less, meaning that we can have all the points within the circle. And again, what I should have done here, something very important. There's a less here. So what we mean by this is that the circumference is not included. So that's a broken circle basically. So this is how it's going to look like. I'm lucky I draw this with a pencil. So here we are. And we can take a look at a third example. All right. So I have this complex number, z plus 5. As you can see now, there's no imaginary part in this one. So we're going to deal with this in just a sec. So the imaginary part is not there. So what does it mean? It means that when you have a real part, the real part is 5. So our center of the circle turns out to be 5 and then 0. And here's a radius. So let's draw a circle. Now if I work to draw this circle, I can try and do it like this. Over here. And say for instance now, if I want to move, let's say 5 units, I'm just going to count it like okay, 1, 2, 3, 4, 5. 5 units is here. And but then again, is that just sort of this is 5 units basically, all right? And so what I want to do is let's suppose that this is 2 basically. I don't want to be to have a big circle there, so that's the reason being. I just want to, let's just suppose now this is 1, okay, 1, 2, 3, 4, 5. Let's say here. You see that's our circle. Circle is going to be, that's the center of our circle, 5, 0. And the radius is now 2. So if I were to put the radius as 2, so there we go. From this center, I'm going to draw our circle with radius 2. So here we are. And now this looks pretty much like it. Oh, sorry, this is imaginary, Z. And then you've got the real part, Z. And of course, this is going to be equal to -3, and this is going to be equal to -7, because you're moving 2 units and 2 units. Now, this circumference is included, and we're going to shade inside the circle. All the points are included, as well as the circumference of the circle. Right, so that's pretty much about it. So here we go. Now we want to move on to half lines and part lines, which basically, when you have an argument of a complex number, z minus z1 is equal to alpha. Now in this, we know that alpha is going to be a fixed angle, and z1 is going to be a fixed point, basically a plus bi. I can have a complex number like this, argument of, let's say, z, okay, plus 2 plus 3i, and all of that is equal to pi upon 4. Basically, we should understand that pi upon 4 is 45 degrees. Okay, so the argument of the complex number, you might have noticed that over here, this is this can be rewritten as minus into -2 minus 3i. The reason I do this is because over here there's a minus, so we have to put the minus, and that is equal to pi upon 4. So now if we were to draw this line, so you've got your diagram like this. And this is -2 and -3i. Okay, so -2 and -3i. Let's say -1 is here, -2, -1, -2, -3. So -3i and -2 minus 3i. So we've got a point here. Now what we do basically, we just draw a horizontal line, a dotted line basically, if you want, just to be able to make the difference. Now that's where our half line's going to start. The angle is 45 degrees in an anti-clockwise direction. And 45 degrees, I'm sure you can estimate, would be somewhere like, if you start from this center here. So 45 is somewhere here. Let's say here. So now, this is the line that we're talking about. So that's the answer. So this is how you draw a half line, 5 and 4. I can probably add something there if I want, but I don't want to combine both of them. You may have circle and a half lines intersecting each other. So let's say if you have a complex number z, modulus of z is equal to 4. Now we know that the center, okay, of this circle is 0, 0, and the radius is 4. So what you do is you go on 0, 0 here, and then draw 4 units in radius, and let's say somewhere here. Okay. So your circle is going to go something like this. Okay. And we can just make this line like this, the circle, and this half line, they intersect at the point P. Okay, so this this is the loci of the both complex numbers, and that's where they intersect each other. All right, so that's basically how we do it. And yep. So basically, this is from my protractor. Okay, I've measured 45 degrees from this here. It may not still not really accurate. So I'm expecting that this line may pass somewhere here instead of there. It could pass over here. It could maybe the point is there, the line is like this. Okay, it depends because this is not drawn to scale. Okay, not to scale, not accurate, not to scale. But again, the idea is how do you draw a half a line, and a circle when you get such complex numbers. Now, because I don't want to keep this video running too long, so I'm just going to quickly move on to perpendicular bisectors. And I'm just going to take an example. Basically, you will recognize when you get notations like these, that these are nothing more but just perpendicular bisectors, where Z1 is a fixed point and Z2 is another fixed point, and they are of the form of a complex form, a plus bi and c plus di. And what we mean by when equal, less, or less or equal, these will include shading the region. All right, but this over here is basically that the perpendicular bisector, the distance from the 2 points, let's say P and Q. I'll explain to you in just a moment what I mean by that after we draw the perpendicular bisector. Let me just take this example here, which is very nice. I've got Z, okay, minus 4 plus I is equal to, let's say, Z plus 5I. So we can rewrite this as Z minus, in brackets, 4 minus I, and equal to Z plus 5I. Now we've got two coordinates, and that's what we mean by Z1. So basically Z1 here is of the form of A plus BI, which is 4I. So that's 4 minus I. There we go. And so how do we draw this? Okay, and if we have, let's say, 4 and then minus I. So 4 minus I, if you just push this a little bit up here. So probably I've got 1, 2, 3, 4. Let's say minus 1 is somewhere here. And I've got minus 2, minus 3, minus 4. So this is 4, and then this is minus I. So 4 minus I is going to come here. So that's my point. Let me just label this point as P. And then the other one is there, which is basically this can be rewritten as Z minus, and then in brackets you've got negative 5I. So this is 0, negative 5. So 0, negative 5 would be somewhere 1, 2, 3, 4. Let's say 0, negative 5 is down here. So I'm just going to call this my point Q, right? And if I were to draw a line over here, and this is it. So joining these two, and because they were perpendicular bisectors, we're talking about perpendicular bisectors over here. So what I'm going to just do now is I'm going to just bisect this line and then get my answer. I'm looking for the locus of points, okay, that are exactly midway between P and Q. So that's how we do it. And of course, you bisect this. Again, accuracy here is not really required, because what you're looking for is what does such complex number represent in terms of a diagram. So here is the answer to the question, right? So that's my answer basically. Okay, so I hope this has been of great help. Like I said, I can't keep this video running for too long. I don't want it to get to make you feel bored. So there we go. Take care.